Alright, so for this next problem, they're telling us to prove this identity, right? So not necessarily easier, but at least we know what the end product should look like, right? So we know that we're supposed to end with 2 secant theta. Our job is to figure out how can we show all the work to get there. Now remember, there's many ways to get there. As long as you follow your algebra correctly, then you'll be okay. And so let's look at the left side. So looking at the left side, notice how there's nothing we can sub. This is not, right? This is not cosine squared theta because there's no square to begin with. And so we're going to have to do something else, right? And so that's what's telling me, okay, so can I combine these 2 equations or these 2 expressions on the left, right? And so in order for me to combine, or in order for me to add fractions, they need to have the same denominator. And so we're going to take this denominator, multiply it up there, take that denominator, multiply it up there. And the reason we're going to do that is because there's a 1. So 1 times anything is whatever you multiply. So I end up with 1 plus sine theta when I multiply this denominator over to the left. And then I'm going to get a plus 1 minus sine theta when I multiply this denominator over to the right. In the denominator, I have 1 minus sine theta, 1 plus sine theta. Now again, these are the factors of a perfect square because it's in the form of 1 plus something, 1 minus that same thing. And so also in the numerator, we should be able to notice that we have things that we can combine, right? So we have a positive sine theta and we have a negative sine theta, which means that they can go together, which will end up canceling it out. And then we also have a 1 plus another 1, which is going to give me 2. In the denominator, we said it's the factors of a perfect square. So when we factor them out, I end up with 1 minus sine squared theta. 1 minus sine squared theta, now that's an actual identity, and that is going to be cosine squared theta. And I can rewrite 2 over cosine squared theta, and if we can't see it, we can also rewrite it in the form of 2 times 1 over cosine squared theta, and that's going to give us 2 secant theta, which is exactly what we wanted to end up with, right? So in this case, we proved it that it is an identity. And so this next problem, number 5, they're asking us to simplify. Now, there's nothing really that we can kind of do from here. So at this point, we're kind of stuck. We can't factor anything out. We can't really do much else, right? We can't substitute anything in, etc. And so what I'm going to go to is I'm going to rewrite each one of these in terms of sine and cosine and see where that takes me anywhere. So cotan can be rewritten as cosine over sine. Cosine cubed theta is going to stay as cosine cubed theta, and cosecant is 1 over sine theta. And then from here, we're going to combine these two since they're multiplying. And we have cosine theta over sine theta minus cosine cubed theta over sine theta. And so now, even though I have 2 fractions again, I can put them together because they now have the same denominator. So when I combine them, I have cosine theta minus cosine cubed theta over sine theta. Now be careful because some of you guys are squaring this when you're not supposed to. The only time we square it is if you're multiplying the same trig function. Now let's focus on the numerator. In the numerator, we notice that we have cosine and cosine, so I can factor out a cosine, and I'm going to be left with 1 minus cosine squared theta over sine theta. And we should recognize that this 1 minus cosine squared theta is an identity, and so we can substitute in the identity of sine squared. So I'm going to restart here. So I have cosine theta times sine squared theta over sine theta. Now since I have a sine squared theta in the numerator and a sine theta in the denominator, the sign in the denominators cancel and one of the signs in the numerator stays. So then I end up with cosine theta times sine theta. And that's as far as we can go. We can't take it any further. Can't rewrite it in terms of sine and cosine because it's already there. It can't factor, can't do anything else. So that's as far as we can take it. Look at the next problem. We have if sine theta is equal to 0.75, cosine theta minus pi halves. They want us to find it. So we should recognize that it is a cofunction, but cofunctions are in the form of 90 degrees or pi halves minus theta. So somehow we got to change this. And so we're going to change it by multiplying by a negative. So I end up with pi halves, positive pi halves minus theta. And so what we're saying now is we have a negative inside my function cosine. Since cosine is an even function, when we put it in a negative, we still get out a positive, right? So we have cosine of pi halves minus theta, which is a cofunction of sine theta. So we got to figure out what is sine theta, which they gave us sine theta. So my answer is 0.75. So cosine of theta minus pi halves is the same thing as saying, or is equal to 0.75.